Hi everyone. In this video I want to talk about another email that was sent to me by an American by the name of Ruben. He didn't want me to give away his full name, but he wanted me to give away his first name. So thank you, Ruben, for this particular email. Now what he was asking was he wanted to understand more about securing basically APIs that are out there in the world. And one of the things he was trying to understand was token-based security. So he's like, "Can you please show me in a video how to do this?" So what I'm going to show in this video is going to be very high level. So I'm not going to be showing things like, what's the format of a token, or how do you implement each individual piece of the puzzle in terms of how to generate a token, all that kind of stuff. But I want to actually just explain the flow of how it works. So I hopefully this answers the question he wants, because he said he didn't really understand the flow or the concept. So I'm going to start now. So the first thing that you need to consider is you have your little API here. So here's your API, and you want to secure it. You want to make sure that hackers can't get in and change certain pieces of your database and all that kind of stuff, and do things that they shouldn't be able to do. So there was a new concept brought into security that's called token-based security. It's also what's referred to as claims-based authentication as well. So the first thing that you normally do if you have a client, which for this to work you have to have a client that's going to talk to the API. So in my case it's just going to be a website. So website in this case is your client. The first thing it needs to do, or the first thing it's going to try and do, is actually make a call to the API. So as you can see here, and I might move this across a little bit. Whoops. Move that over. Move that over. So I'll move this over a little bit. Join these two bits together. So maybe just move that over to the corner there a little bit and a little bit down. So you've got your website. It makes an initial request. Now this is with no security at the moment. Or actually the API does have security in it. So just say we've already set it up, and behind the scenes it's looking for a token. Okay, and that's what this idea of token-based security is. It's looking for a specific set of data that you send to it called a token. Now, at this stage, your website, you know nothing about what this token-based security is, so you make a request to it. And what ends up happening is that you get basically a response from the API saying, "You're not authorized to access this API. Go and see this service, and I'm going to provide to you the URL called a security token service." And what it is short for is STS. So you've got your STS. So what happens is it says, "Go and have a look at the STS," and it's got a URL and everything. So then basically from that, the website now goes, "Oh, okay, so I've got a URL where I have to go and authenticate myself because I can't do it through the API." So then what happens is you go and you redirect to the security service. Right? Now, in this example, I want to keep it fairly brief because there is multiple ways of doing this, but generally in most scenarios, when you go to the STS or the security token service, you will get a login page. In most cases, this is what will happen. There's an advanced case where you log in through other channels, and then you come and generate a certificate, a token through the STS. But for the most part, when they say goes to the STS, you're going to be going to a login page. When this happens, what you're actually also going to is something called an identity provider. So an identity provider is basically a place where you can go and you can log in as you would in any website. You log into the system, and then what happens once you've been authenticated successfully, so the STS knows who you are. let me move this down just a little bit. What will happen next is it will issue a token, right, back to the client. So this is now going back to you. You now have a valid token for this particular API now. Now the question is, how do you know, or how does the STS know how to create these tokens for this API? Well, the bit that you don't see before we start the negotiations here is behind the scenes, there's already been a trust established between these two APIs. So this trust here is saying, I'm an API and I'm only going to trust this service here as my identity provider or even my issuer of tokens, and I'll only accept tokens from this issuer or this token service. So if this trust is not established, getting a token from here will be pointless anyway because the API will not understand it. So the key part is to establish the trust in the first place, right? So the trust has been established. You've now got a token back that will now be accepted by the API. So the next thing to do, obviously, is when you make the request again, you send the authorized token along with it. So now you've got an authorized token-based request. And that's pretty much it for the most part. The other thing I want to mention too is the API is also referred to as a relying party. So this relies on this security token service to issue the correct tokens for this to be issued, for the website to be able to make requests to this API. So this relies on this, so that's why it's referred to as a relying party. Now, you've got your tokens, you're passing information backwards and forwards, and everything's good. Alright, so where is this secure, will you say? Well, firstly, and most importantly, when I'm making requests to the API, at no point am I ever sending my password or username through to this API. This API knows nothing about what your username and password is. The trusted relationship of username and password is established by this identity provider, or in this case, it's both a security token service and an identity provider. Okay, so it knows where your credentials lie. You know, it could be in a database, it could be somewhere out there. This API doesn't need to know about it. It says, I don't care what their credentials are. If you give me a valid token that's been created by this thing, I'm all good. I don't care. All right? I'll just continue to use the token that you give me as long as it's not expired and it's valid. Right? So that's where this sits in. That's where the established relationship of authentication takes place. Now, there's one other scenario that's also covered here. This is not the most optimal solution in terms of preventing you being hacked. Now, what can happen is, even though a hacker from this channel here may not be able to get access to the username and password of somebody, they can still hijack the token and do things on the API. So you say, well, what's the point then? I might as well send the username and password, other than the fact, you know, they can use the username and password somewhere else. I can still do things. I can still hijack somebody's token and do dangerous things. Well, what they generally do in these situations is that this token that's generated by the STS is given a very short lifeline. So it might be that it lasts maybe 5 minutes, it might last 30 minutes, it might last an hour. It really comes down to the configuration of the security token service and how long these tokens survive for. But what they generally do as well, which you as a developer have to be very careful to manage, is they also issue, along with the token they issue, a refresh token. Now, what's a refresh token? Well, what it is it allows you to come back up to the security token service and acquire an absolute new token after it's expired without having to log in again. So does that make sense? So you come here for the first time, you make a request, and it goes, no, can't you're unauthorized. You didn't bring me a token, right? Go and have a look at the security token service. I need the token from there, right? So then the client goes, oh, okay, you give me a URL, cool. I'll go and redirect up to the security token service, which in this case also happens to be the place where we identify who you are. So this STS and this IP, they can actually be two separate entities. Okay, the IP can actually be stored on another machine somewhere, and the STS is just responsible of translating the token from the identity provider to this security token service, which will then create another token, which will be understood by the API. But I don't want to get too complicated into that for the first example. Basically, the simple example is you don't have a token, I'm unauthorized, we redirect, we come in, we authenticate through a username login page. We do that finally, yep, all successful. We grab a new token, right? And we continue to make requests to the API. Oh, token's expired. Okay, what do we do now? Well, what happens is the client keeps a hold of that refresh token that I just mentioned. And then once it realizes it's expired, it actually goes and acquires a new token, fresh one, using the refresh token that it's stored locally in the client. And what that does is now it allows us to continue to grab the access token and reuse it in this API relationship. So now, what does that mean in terms of a hacker? Well, the hacker can get a token for maybe the maximum of 5 minutes. They can do some damage over a period of 5 minutes, right? But once that happens, or once that expires, they can't do anything there anymore. And maybe in that 5 minutes, this API or whoever's behind the scenes here has detected a hack. And then once they've done that, they can take certain actions to shut down the middleman attack. It could be that they turn off the API, or they've got some other techniques in order to shut down middlemen. But for the user, when it actually expires, right, because they've got a hold of the refresh token, they can just go and get another token and just keep going, right? And it just continues on. Access token goes and expires, new refresh token goes and gets another one. And the process loops and loops and loops and loops, right? It loops for only a certain period of time, obviously, and that's because the refresh token itself has an expiry on it. And that would be based on some configuration on the STS, or actually more so probably the identity provider. Because you want people to eventually authenticate and log back in. Now this could be 30 days. Like a lot of sites you'll see, keep me logged in for 30 days. That's kind of what they're referring to. They're referring to, if it's a token-based system, they're referring to how long does the refresh token live for. That's what they're saying in that situation. Okay? So I hope this helps with the basics, at least, of token-based authentication. Now, in terms of storing the token, what I've done in the past, when I've had this kind of a setup, is if you're accessing the API from the server end, so just say the client in this case is the web server, not the web browser itself. So it's not making AJAX requests to the API, it's making server-side requests to the API. Well, you can store the information in session state or some kind of session behind the scenes, and then store a identifier for that session in a cookie, and make sure that cookie does not allow client-side access to it. And you can do that by making sure the cookie is HTTP only. So if you don't know what that means, you can look it up, but look up HTTP only cookies and you'll understand what I mean there. But that's what I've done in the past. I've stored a session-based identifier in a HTTP only cookie, and then I've gone and gathered the information, like such as refresh token and all that, from session, and whenever the API call is no longer able to be processed, then I go up and get a new token using the refresh token. And that's the process I've done there. Now, for the client side, I haven't particularly done this myself, but I have seen plenty of examples of client-side ways of doing this, and what they generally do is they store it in something called session storage. So in HTML5, there's a concept of local storage and session storage. So a lot of people will store the refresh token and even the access token inside of session storage. Now, that is somewhat secure. Local storage is definitely not secure. Anyone can access that by doing a quick JavaScript hack. However, with session-based storage, for the user to hack it, they would have to basically be in the same session as you in order to acquire it, which is not easy to do. So that's a little bit of thought there. But basically, this is the obvious flow, and maybe in the next video, if I do another one on this, I can show you where something like Facebook fits into this process. But basically the idea is that this IP, so if I go and create another box, so instead of having STS, I'll just ungroup this. So I'm using Illustrator to do this. If I take that away and then I bring this to the front, range, bring to front. So what normally comes here is you basically go, website tries to make an API request, and goes, no, we don't want to, we need you to authenticate, right? So you come here, and maybe you come up to this site, and this site has a potential website logo, but it might say, hey, look, you've got a choice of logging with Facebook or Google or something like that. In which case, you click a button, and it comes out to you whatever one it is. So in this case, it could be, I don't know, it could be Facebook. You log in with Facebook, or you're authorized with Facebook to allow access from this API, and that generates a token. That token then comes back to this security token service. It then translates that Facebook token into its own kind of token, and then the process repeats itself. Okay, and then you're using the same token-based authentication process. And the only difference is that the token from Facebook is acknowledged that this state kept stored somewhere and translated into its own version of the token for the API to consume. Okay, so that's it for this video. Thank you for watching, and I hope that answers the question, and I'll see you next time. Thanks.